Hey everybody, here's Mr. Longo again, and we are going to take what we learned about feasible regions and inequalities, and we're going to answer a word problem which is known as linear programming. So we're going to take some constraints and we are going to figure out, solutions to a certain situation. So the first thing we're going to do is read this and say that we're going to go to the store and buy some new socks. We want to buy at least 5 pairs of socks. Red socks are $4 a pair. Striped socks are $5 a pair. We only have $30 in our pocket. So if X is going to represent red socks and Y is going to represent striped socks, then we need to start writing some inequalities. So we know that the sum of red socks and striped socks, we want to buy at least 5 pairs, so that needs to be greater than or equal to 5 pair of socks. Now we got to talk about some money. Socks, if they're red, they're $4 a pair, so we have $4 a pair for red socks and $5 a pair for the fancy striped socks, but we only have $30, so that has to be less than or equal to $30. And of course, what you would want to do with both of these is make sure you write them in graphing form. So y has got to be greater than or equal to a negative x plus 5. And y has got to be less than or equal to negative 4/5 x plus 6. So of course, the next part is you're going to shade and graph these. So we have negative x plus 5. Again, when you are graphing in terms of a feasible region, you want to be as accurate as possible. So you might want to consider graphing every point that you can. Okay, so we are going to be above that line, which makes sense. If you buy 1 pair of red socks, you can buy 4 pair or more of striped socks if you have the money. Okay, 2 pair and 3 pairs, 5. We want at least 5, so that makes sense. But remember, we are also restricted by our money. So if we graph 6 and use a slope of down 4 over 5, and then down 4 again over 5, that's going to put us off the grid somewhere down here. But if you think in terms of a fraction, if you're going down 2, then you'd be going over 2.5 units. Okay, and again, we are restricted by the amount of money we have. So we're going to be shading below that line. Again, we can't spend any more than $30. So our range that we are allowed to buy socks and spend is right there. So under these conditions, could you buy 4 pair of red socks and 1 pair of stripes? So remember, X is red, Y is striped. So can you buy 4 pair of red and 1 pair of striped? The answer is yes, you can. How can you tell? Yes, and the reason is because it fits in the feasible region that we learned, because it's on a solid line, so that counts. We are allowed to do that, and we are allowed to be on a solid line, okay, because we want to buy at least 5 pair of socks. It looks like we have enough money to buy 5 pair of red socks and 1 pair of striped socks. We have enough to do 4 red and 2 striped. Anything in this region is fair game. Okay, so continuing to look at this, it says you decide that you're only going to buy striped socks. So if you're only going to buy striped socks, remember, striped is Y. What is the maximum amount of money you will spend, and how many pairs of striped socks will you get? So we're going to look at Y, and we want to be as high up as we possibly can, but still be on or within this feasible region. So it looks like the most we could buy is 0 red socks and 6 pairs of striped socks. So the most we're going to do is 6 pair of striped socks, and that's going to give us, at $5 a pair, that's going to give us exactly $30. So that is the maximum we can buy in terms of striped socks. Now I want to flip the script on you on this problem, and I want to ask you now, If you were only going to buy red pair of socks, if you were only going to buy red, how many could you buy? How many could you buy if you're only going to buy red socks? So let's think about that. Red socks is X. So sticking in the feasible region, looks like it would be 7. Okay, so if we're going to do red socks, it would have to be 7 pair. And then you have to think that's $4 per pair, so that's $28. So you would have $28 spent, which is less than or equal to 30. The question is, why can't you go to 8? Well, can you buy 7.5 pair of socks? No, that would be weird. But can you go all the way out to 8? No, because 8 times 4 is 32. That's more than the amount. So if you're on a fraction, you have to just kind of think about it a little bit, okay? So that's what's going on with striped socks, and then of course red socks. The last question is, why do you only need quadrant 1? Well, the question of the day is, can you buy negative pairs of socks? No, you can't. You can't take your socks from your drawer, bring them to the store, and say, here, let's trade. You take 4 of my socks, and I would like 4 of your socks for free, and then, no, not going to work. So you can't have negative socks. You also can't have negative money. So there you go. That's why you can't use, or you only use quadrant 1. There's another example problem if you would like, but it's almost identical to this one, so you can go right ahead and try that one if you'd like. This is Longo, and I'm out. See you, bye.